Why does trash in a park tend to collect in the same places? Take this tunnel at the bottom of that hill. No matter where the trash starts, it often ends up right there, unless it's a windy day. This simple observation helps us understand one of the biggest ideas in chemistry. There are two driving forces in thermodynamics. The forces are strong with this one. Let's break them down. The first driving force of thermodynamics is the tendency of a system to move toward lower potential. For trash, that means gravitational potential energy. Gravity pulls it downhill, so it naturally collects in low spots like this tunnel. In chemistry, potential energy comes from molecular interactions. But the principle is the same. Systems tend to settle into arrangements that minimize energy. However, energy isn't the only factor. Think about what happens on a windy day. The trash gets carried everywhere. That tendency to spread out is called entropy in thermodynamics. Energy and entropy both shape what happens, whether in a park or in chemistry. Understanding energy and entropy helps us predict whether a reaction will happen and what conditions tip the balance. In a way, thermodynamics helps us use the force, not to move objects with our minds, but to harness the natural tendencies of matter and energy. In this unit, we'll explore the two driving forces of thermodynamics and how Gibbs free energy, or delta G, combines them to determine spontaneity. We'll also analyze entropy from both qualitative and quantitative perspectives to better understand its role in chemical processes. The first law of thermodynamics tells us that energy is conserved, but the second law, governing spontaneity, is just as important for understanding how things happen. It helps us predict which processes occur spontaneously and under what conditions. The balance of energy and entropy doesn't just drive reactions. It drives everything from the cells in your body to the engines on the road. This is real chem.